3.7 Graph linear functions. Function notation. Recall from pre-algebra that we can write y as f of x. And this would equal to mx plus b. Okay, and the symbol f of x is another name for y and is read as the value of f at x, or as I was saying, f of x. It does not mean f times x. Any letter such as g or h can be used to name functions. Family of functions is a group of functions with similar characteristics. So if I give you f of x equals mx plus b, you can come up with many types of equations following this format, and they will all look like lines, and we call that a family of functions. The parent linear function is the most basic linear function, f of x equals to x, which goes through the origin 0, 0. And for every y, it would every x, it will equal to y. Okay, and moving on. Changing m or b in the general linear function g of x equals to mx plus b creates families of linear functions. Whose graphs are related to the graph of f of x equal to x. And remember, this would be referred to as the parent function. Okay, so now I'm going to explain how to compare graphs of linear functions with respect to the parent function. Okay, so if I give you g of x equals x plus b, I can label this graph as g of x equal to x plus 2. And this graph would be g of x equal to 1, 2, 3, x minus 3 because it shifted down 3 units. And for the other one, it's plus 2 because it shifted up 2 units along the y-axis. Okay, and now we have the parent function, and this would be referred to as, we'll use f here, f of x equal to x, and I got this from here. Okay, and let's analyze this. The graphs have the same slope, one, 1, 1, but different y-intercepts. Graphs of this family are vertical, translations of the graph of f of x. And now we have the case where g of x equals to mx and where the slope m is positive. Okay, I'm going to let this line here be the family parent function, f of x equal to x, and this graph be g of x equal to 2x, and I'm going to let this one be g of x equal to half x. I actually can use a different letter here, but let's just make things simple. The graphs here have different slopes, positive slopes, but the same y-intercept at 0, 0. Graphs of this family are what we call vertical shrinks or stretches of the graph f of x equal to x. When we have a vertical shrink, the slope is between 0 and 1. And when we have a vertical stretch, the slope is greater than 1. So if we look at g of x equal to 2x, the slope here has stretched from 1 to 2. That's why it's steeper. And we can describe this as g of x equals to 2x is a dilation or vertical stretch of the function f by a scale factor of 2. And for g of x equal to half x, maybe I could use h instead. H of x, or just simply h, is a dilation, vertical shrink of f by a scale, let me write it down here, factor of half. So I'm going to draw a line in between here so you don't get confused. Okay, now we have the case where g of x equals to mx where the slope is negative, m less than 0. Let me first label these graphs. F of x equal to x. And this graph we would have to reflect about the x-axis so that it would take a negative slope of 1x. And this graph here, I can let that be f of x equal to negative 2x because it has stretched a little bit. Okay, the graphs here have different negative slopes. But the same y-intercept at 0, 0. Graph of these families are vertical stretches or shrinks with reflection in the x-axis of the graph of f of x equal to x. This reflection in the x-axis refers to this negative sign here. So this graph has reflected about the x-axis and forms a perpendicular angle here. Okay, and then if we stretch this graph a little bit towards the right, where the slope becomes steeper, I can say that this graph will have a scale of a dilation with a scale of factor of -2. And again, I want to repeat that this negative just tells you that the graph is reflected about the x-axis. So again, I'm going to write it right here. F of x equals to -2x. This is the negative sign refers to the reflection. The slope or the scale factor refers to how dilated the graph is, or whether it's stretched or shrunk. So again, if it's stretched, it's going to be greater than 1. And if it's shrunk, it will be between 0 and 1. Evaluate the function when x equals -3, 2, and 4.5. So when x is -3, I can substitute -3 in for x. 5.2 times -3 is -15.6, and -4 will give me -19.6. And when f is 2, it's going to be 10.4 minus 4, and that's going to be 6.4. And when we substitute 4.5 in for x, we'll get 5.2 times 4.5 minus 4, and this would give me 23.4 minus 4, and this would be 19.4. And now we have h of x equals 8.5 minus 10x, and we substitute -3, it will be 8.5 minus 10 times -3. This would be 8.5 plus 30, and this would be 38.5. And when h of 2 will be 8.5 minus 10 times 2. This would be 8.5 minus 20, and that would give me -11.5. And when h of 4.5 would be 8.5 minus 10 times 4.5. This would be minus 45. And again, -36.5. Here we go. And for these questions, for the given function, find the value of x so that the function has the given value. So this would be the given value. f of x. And we need to sub that in for f of x, -7, and solve for x. So then 8x would equal to -16, and x would equal to -2. And let's do one more. So substitute 26 in for p of x, and it would be 14 minus 4x, and 4x you'll equal to 14 minus 26. 4x would equal to -12, and x would equal to -3. Okay, graph the function. Compare your graph to the graph of f of x equal to x. First, I'm going to graph f of x equal to x, which is just this. Okay, I'm going to use a different colored pen. G of x equals to x plus 3. My y-intercept is +3, so I'm going to start here. And my slope is 1/1, so I'm going to shift up 1 unit and then make a right turn and shift 1 unit to the right. And end up at the point 1, 4. And I'm going to graph. Okay, so what happened here? How can I compare this to the parent graph f of x? I can just say g of x is shifted upward by 3 units from f of x. And for this one, we graph the parent graph. And this graph here stretched. Okay, so since the y-intercept is 0, I can start at point 0, and then I can shift 2 units up and 1 unit to the right. So 2 points, and connect the dots. So therefore, h, or the graph of h, is a dilation, or what do we, vertical stretch of the graph f by a scale factor of 2. But if we have, let's say, g of x equal to -2x, we're going to have a reflection about the x-axis. And this here we can say h, or g I mean, is a dilation vertical stretch of f by a scale factor of 2 with reflection in the x-axis. Again, this reflection just means the negative sign. The scale factor refers to how dilated the graph is. And when it's positive, again, this positive 2 together tells you what the slope is. Negative 2 together tells you what the slope of the graph is. But if we separate the parts, it means different things. So the 2 alone here tells you the dilation. Okay, and the signs tell you, okay, positive, then we don't have to worry about any reflection. When it's negative, it's going to be reflected about the x-axis. Word problems. The number of hours people in the United States spent using the internet each year from 1998 to 2001 can be modeled by the function f of x equals 26.4 plus 54.4, where x is the number of years since 1998. So you need to let 1998 be year 0. Okay, so here, part A, it wants you to graph the function and identify its domain and range. So I'm going to first write D for domain and range, R for range on the side. And I'm going to go ahead and graph this. So I need to first graph the y-intercept of 54.4. So that's about right here. Okay, so between 1998 and 2001, we have 3 years. So we can go ahead and take f of 3, 26.4 times 3. Put an x in, I forgot to type it, and plus 54.4. And then we can go ahead and evaluate this. 79.2 plus 54.4 gives you 133.6. So when it's at 3, we have 133, so we can sort of round the point. And we can go ahead and connect the dots. Therefore, the domain will be between 0 and 3 inclusive, and the range will be from 54.4, where the y-intercept is, and 133.6. So right here, 333.6, and this will be 054.4. Part B. Find the number of hours that people spent on the internet in 2000. So in the year 2000, that would be considered year 2. So 1998, 1999, 2000. So therefore, we can plug in 2 now. F of 2 will be 26.4 times 2 plus 54.4. That would equal to 52.8 plus 54.4, and that would equal to 107.2 hours. The next one. When did people spend about 120 hours per year on the internet? So in this way, it's just the opposite. We need to substitute f of x for 120 and find out the time. So we subtract 54 to both sides. This goes out. So 65.6 equals 26.4. And x would equal to about 656 divided by 264, and that's about 2.5 years. And we would say that would be around 2000.5, but it's kind of weird to write your answer like that, so you could say middle of 2000. Okay, and that concludes the lesson.